Hi, my name is Ricardo Ruiz, and with the help of my colleague Josue, we will talk a little about the history of industrial robotics. We are students of the Polytechnic University of Aguascalientes of the Electronic Engineering career. First, it's important to mention how robotics was born. Robotics was born thousands of years ago when it's not yet known as a science of study of the robots, and robots were known as automaton. An automaton is a machine that mimics the figure and movements of an animate being. As we know, the human being has always wanted to create artificial life that facilitates his way of life, and at that time, the automatons were created in order to entertain their owner. The history of robotics is linked to the construction of machines that try to materialize the desire of the human being to create beings in his likeness and to decrease him from work. The ancient Egyptians attached mechanical arms to statues of their goods. The Greeks built statues that operate with hydraulic system, which were used to fascinate temple worshippers. Clear examples of automatons. Getting a little into important dates and events in the history of robotics, in Spain, it was known the Man of Stick, built by Leonardo Turriano in the 16th century for Emperor Charles V. This automaton, in the shape of a mug, walked and moved its head, eyes, mouth, and arms. In the year 1920, the term robot was first used in the play by sketch writer Karel Capek, RUR, Rossum's Universal Robots. The word robot is a term that comes from the word robot, which means servitude or enslaving work. In the year 1937, the British student Bill Taylor created the robot Gargantua, a robot shaped like a crane for which he used components that were used in the toys of Meccano. This robot was used for product placement, which industrial language is known as pick and place. It was programmed with paper tape and motorized with a single electric motor. Gargantua was able to stack wooden blocks in programmed patterns. In the year 1938, the Bilbis company built the first robot shaped like an articulate arm for spray painting. At the annual fair in New York in 1939, robots for industrial and leisure use were already present. This made the beginning of one of the most interesting industries in the history. In the year 1939, robot, the first humanoid robot, Electro, was introduced. A main motor was built by the Westinghouse. It was 2-meter machine that could walk and had a recording of 700 words for the artifact to simulate establishing a conversation. It was exhibited at the Universal Exhibition between 1939 and 1940. It had aluminum skin, 120 kilos of weight, and thanks to photoelectric cells, could see and distinguish colors such as a green and red. In the year 1942, the term robotics was coined by Isaac Asimov, who defined it as the science that studies robots. Asimov also created the three laws of robotics, which are the first law: a robot cannot harm a human being or by inaction allow a human to suffer harm. The two law: a robot must obey orders given to it by humans, except when such orders conflict with the first law. The third law: a robot must protect its own existence as long as such protection doesn't conflict with the first or the second law. In the year 1954, George Devol and Joseph Engelhard patented the first industrial robot. Years later, they founded the revolutionary company Unimation to manufacture the robot and coined the term universal automation. In the year 1954, the first digitally operational and programmable robot was invented by George Devol and Joseph Engelhard. It was called Unimate. This later led to the foundation of the modern robotics industry. In the year 1960, Unimation developed the industrial robot Unimate. It was the first robot integrated into a production line of a leading company. In the year 1961, the Unimate was installed at a General Motors plant in Ewing Township, New Jersey, to lift hot metal parts from a die casting machine and place them in a coolant. In the year 1969, Victor Feynman invented the Stanford arm at Stanford University, the first multi-programmable, lightweight, all-electric robotic arm. Subsequently, he sold his designs to Unimation. In the year 1970, Cheikei was born, the first mobile robot controlled by artificial intelligence. It was also created at Stanford. This robot already incorporated touch sensors and vision camera. He could move around the ground thanks to two computers, one on a board and one remote, that were connected by a radio.
So the next step for industrial robotics, it was in 1970s, produced by Shaki. It was a very important step for the industrial robotics for the United States. In this case, because the Shaky, um, uh, or create the first mobile robot controlled by intelligence, artificial intelligence. So it was very important because it was also created for Stanford, and it was awesome for the United States. But this one, it was a big step for the artificial intelligence. So the next step for the industrial robotics, it was in 1973 when KUKA produced the first industrial robot called Famulus. Um, it was a important robot because this robot has 6 axes, electromechanical, the in the function of the of so the 6 axes by a driven, but it was driven electromechanical. So then the next step was in 1974. So it was very important for this year because in this year it was the first microcomputer uh, in the world. So the microcomputer, it was controlled by electrical, industrial robot. It was I the name, it was IRB. um the prototype, it was the 6 IRB6, obviously from ASEA. was delivered to a small mechanical engineering company in Sweden, more specifically in the south. So it's southern Sweden. So the design of a robot had been patented before this year. It was patented in 1972. So the next step for the industrial robotics, it was in 1975 by Victor Schemann. It was very famous robot, because Victor Schemann created the famous robot Puma. So it was the pioneer in robotics company in animations. Um, this robot begins to work in General Motors to assembly tasks. So it was a very big step for the robotics, for all the sentences, because it was better for the economy and more faster for the produce of the company. So the next step was in 1978. Um, it was the first programming language. Um, so for the allowing robots to handle variation to object positions, shape, and sensors noise. So it it, it was very different for example the Puma. It was different for the sentences of the of association with industrial, and sentences with sensors. Yeah, are different for many sentences. So the next step for the industrial robotics, it was in 1983. So it was important for two sentences. So it was the first multitasking parallel programming language. So it was used for a robot control, but it was the event driven language. And the IBM, all we know all the IBM. So it was very a competitive company in the question of programming, but in these sentences it was the first series to process computer. So this one has a implementation of both interprocess communication. So it's wait and post. So it was an important decision for the the mutual exclusion. It was the difference in N INQ and the EQ. It was mechanism of robotics control. So it was a big step for the robotics. So the next step, it was in 1992. So because it is more a robotic, um, more specific, because the Boston Dynamics um, was founded from the beginning. They were interested in creating robots. In this case, it was very special because they inspired in animals. So all the things that the animals can do, you can replace a lot of things that the humans can do. So no replace like that, but just better the sentences to do more easy the things. So in this case, it was very special for the robotics in general. So in the last one part, it was in 90 sorry, in 2000, because it was introduced the first robot called Asimo, produced by Honda. So it was a very long work. This work is the first one in inspired in a work of 1987. Yeah, in 1987, because it was a very long work. So this work, it was awesome for the things of the sentences of the human can do. So just you think in things like catch an apple, or move like Puma. It was the a robot that catch I don't know, maybe an apple, and do in our place. It was maybe in 1970s. Nothing believed that a robot can do that, but in this case, now it's possible. It also for for the sentences that now have a very extensive language of the programming, the robots can do anything. So obviously, taking in count the rules of the robotics that in past years the was founded, but in this case it was awesome. So for the conclusion, and I don't know, maybe you can do a lot of things with a robot. So the first one of that was the things that people can do, but no fixing robots for people, humans. You can't do that for the rules, but yes, can help for do more easy the work. So if you have maybe a work doing part of the cars, yeah, maybe 20, 30, or 40 years before, you need to do so with hits. But now you don't need that, you don't need to do that, because the robots help to do. You can do now programming the robot. You can do the job more easy, and not you can think now in, oh, the robot fixed now me to a robot. No. They help you to do more easy. Starting with Puma was very very important for the starts of the industrial robotics, for the mechanism, all the things. So after that, the six axis, I don't know, yeah, now you can do a lot of things with robots. So now this robot is for help you, not for change you. No. Maybe you can do the things more competitive things. Now you can programming the robot. The robot can do all the things, yeah, that you want to do. It's a help for you. So with this conclusion, we finished the history of industrial robotics, and with all the things that you can do. You can do anything. You can work with that.